Hello everybody, I am Sanjay Rai here. Today we will discuss about an important topics in physics, which is moment of a force. Now what is moment? Moment is a cause by which an object has a tendency to either rotate or tends to rotate. Suppose this is an object. If I apply a force anywhere, what could happen? Suppose I have applied a force along this direction, so this will have a translational motion or rectilinear motion. That means it has a tendency to go along a straight line, right? But suppose it is pivoted at any point. Pivoted means suppose there is a hole, pinhole, and I have suppose insert a pin here, and if I apply a force, okay, now what is the, now it has a tendency to rotate either clockwise or anti-clockwise. Okay, so this is the moment. Now what is the measurement of that moment? Now moment is measured by the magnitude of that force and the perpendicular distance from the point of pivot to the line of action of force. Okay, suppose this is a force. Here this is a force I have applied here. Okay, and okay, suppose this is an object. Here is a point where it is pivoted. Now suppose I apply a force in this direction. It will not have translational motion. Why? Now this is pivoted here. That means it can freely move clockwise or anti-clockwise, but it can't go rectilinearly. Okay, so what is the moment? The moment is the measurement of this force, magnitude of this force into the perpendicular distance of this line of action of force from the point of pivot. Okay, that means it is the F into OA, means magnitude of force, moment equals to magnitude of force into OA. Okay, now moment is a vector quantity. Why? It has magnitude as well as direction. Why? Now suppose this point of application is here. If I change this line of action of force from this point to this point, A dash, then the body will rotate in the opposite direction of the previous one, right? So if it is considered, it is for this force, a force, it has a tendency to rotate anti-clockwise. Okay, but by the application of this force, the same force, but the line of action is different. So this force moves the object towards this direction, means clockwise direction. So what is there? Only due to the change of line of action, change of point of application, the direction of rotation differs. Okay, So that is very important. So there is a direction factor is there. So magnitude is not only the sufficient but parameter, but we should have the magnitude and direction both. So that's why moment is a vector quantity. What is the unit of moment? In SI, the unit of force is Newton, okay, and unit of distance is meter. So unit of moment is Newton meter. Moment is also called torque. We can say torque equals to force into distance of the pivoted point from the line of action of force. So how can we change the moment? Now there are two parameters. Number one, we can change the magnitude of force, and number two, we can change the point of application line. We can change the distance of the pivot point from the line of action of force. Okay, that means suppose this is an object and it is pivoted at this end point. Okay, if I apply a force here, that means force into perpendicular distance. This scale is suppose 10 centimeter, 15 centimeter long. Okay, so 15 centimeter, this length into force, line of action of force is this one, line of action of force, and perpendicular distance of the line of action of force is that much. Now if we reduce this, that means if we reduce the distance, okay, so tendency of rotation also reduces. Okay, as this length increases, the tendency of rotation increases, means moment increases. Okay, and if we increase the force, definitely the rotation, the tendency of rotation will be more. Okay, so by changing these two factors, by changing the magnitude of force or by changing the distance of the pivoted point from the line of action of force, this can be changed, means moment can be changed. Now somewhere we need to increase the moment. Okay, in practical day-to-day life, we may have several experience of moment. Suppose, let us see a door. Suppose this is a door. Here we see a handle and the door is hinged here. Okay, now the handle is fixed as far as more distance from the point of pivoted point, means where this is hinged. Okay, why? Now if this distance increases, then we will get more moment by applying a less force. This distance is increased, moment will also be increased. So this is fixed as far as distance from the point of pivoted point, the point of pivot. Okay, similarly you people may have seen this instrument. This is called wrench or spanner. It is used to unwind or to tighten a nut or a bolt. Okay, now by this wrench we can easily loose or tight a nut or a bolt. Okay, bolted. Now what happens? Now here we apply force so that it rotates. Okay, now this handle, if this handle is very long, then it will be easier for anybody to rotate it or to loose or tight the nut. Okay, so this is an application of moment, so that we can increase or somewhere we can also decrease the moment. In a bicycle, the pedal, it revolves the wheel. Okay, so there is also application of moment. In fact, in our daily life, if we open our eyes, we'll see many practical things, many practical phenomena where we are using the moment. Okay, now sign of moments, symbol. Since I already told you that moment is a vector quantity, okay, that means it has magnitude and direction. And as we have seen, the moment can be clockwise or can be anti-clockwise. Okay, it can rotate in clockwise direction due to a moment, or it can rotate anti-clockwise direction by a moment. Now, if we see from our side that that the object has a tendency of rotation in anti-clockwise direction, then that moment is considered as positive moment, though it is relative. From the opposite side of the object, our what we see anti-clockwise, that could be clockwise from the opposite side. Okay, but from our side we will see that if the tendency of rotation or rotation is in anti-clockwise direction, then it is considered as positive moment, and vice versa. Okay, now if a body does not move after application of also so many force, then the body is called that it is in equilibrium. How many kinds of equilibriums could be there? If an object does not move in a straight line, okay, suppose this body is in rest, this is absolutely in rest. Okay, there is no movement, neither rotation nor translation, no kind of movements is there. So this is called equilibrium of rest. But equilibrium can be dynamic also. How dynamic? Now suppose I have applied some force in this direction and also in this direction, okay, but the magnitude of forces are different. Suppose here 4 Newton and in this direction is 2 Newton. Though the forces are opposite, the forces are acting towards opposite direction but same line of action, so it will have a movement in this direction by the application of that unbalanced force. Means here 4 Newton and in this direction 2 Newton, so unbalanced force 2 Newton is acting towards this way. Okay, so this will have a dynamic motion, this will have a motion, rectilinear motion. But suppose the body was moving, already it was moving with a uniform speed, with a uniform velocity, then if there is no unbalanced force, it will have a tendency to go along a straight line with the same uniform velocity in a straight line, as per Newton's second law, we already have learnt earlier. Okay, so this is called dynamic equilibrium. Dynamic means this is not fixed, but dynamic equilibrium can be rectilinear as well as can be rotational. Suppose a constant moment is there. Okay, if we apply a moment, this will rotate, but if it was already rotating, then if we apply a moment, unbalanced moment, then the rotation will either be increased or will be decreased. But if there is no application of some other moments and it was already rotating with uniform angular velocity, means rotational speed is same. Okay, that means it is in equilibrium. Maybe there's some moments are acting, but the resultant of the moment is zero. That means total clockwise moments and total anti-clockwise moments are same but opposite. So this unbalanced moment cannot change the speed of rotation of this object, right? That means angular velocity cannot be changed. So that is called rotational equilibrium. So equilibrium is basically of two: number one, statical equilibrium, and second is the dynamic equilibrium. And dynamic equilibrium are also of two kinds. One is translational dynamic equilibrium and another is rotational dynamic equilibrium. That means if a body has to be completely in equilibrium condition, then the net resultant force must be zero and the net resultant moments must be zero. Okay, now second thing, couple. Basically, a force, an isolated force applied on a body is not possible. We know as per Newton's third law of motion that there is an equal and opposite reaction of any force. Now suppose a force is applied, here. Give me another example. Suppose this is a bottle. If I apply a force to open this lid, that means I am applying a force in this direction and applying another force in this direction. Okay, the forces are in different directions, in opposite direction. Okay, but there is a distance between the line of action of force. So actually there is suppose, let's see the picture diagram. Okay, this object is pivoted at this point and there are two forces F and F are acting in these directions. The directions are opposite in nature and the magnitude of force is same, F. So there are two moments. This moment is F into this length. Suppose this is X, this dimension is X, this length is, distance is X. So this moment means this clockwise moment equals to F into perpendicular distance of the line of action of force from the pivoted point, F into X. Okay, but for this force, this is an anti-clockwise moment, right? By this force we are getting an anti-clockwise moment and this is F into Y. So total moment, this force acts in anti-clockwise direction. This is also acting in anti-clockwise direction. So net force, total moment equals to F into X plus F into Y, right? This moment tends to rotate the body in this direction. Okay, similarly this force also tends the body to rotate in the same direction. That means we are doubling the moments, F into X plus F into Y. Now if we take common f, then f into x plus y, x plus y. This x plus y, this the distance of the two forces, perpendicular distance of the two forces is x plus y. This is called couple arm, and this kind of moments is called couple. Okay, couple means nothing, two equal and opposite forces are acting on an object to rotate the object. Means here are two moments. Okay, so we see couples basically to rotate like the water tap. Okay, like to open or close the bottle lid. Okay, pen, sometimes the lid of the pen, etc, etc. Okay, so that's all about the moment. I feel you people will have some knowledge. If you feel better, if you feel that this demo is useful for you, then please subscribe my channel. Okay, and see every time, make close watch on my TV, on this channel. Okay, thank you. I will try to deliver more and more videos on many topics. Okay, thank you for today.